Hi class, let's take a look at problem 23. Now, they're giving us the following formula, and for this type of problem, since we're not given the actual equation or mathematical model, we first need to find k, which is a decaying constant. So let me just start with find k. Now for k, we're going to use basically what's given in here for this formula. So in this case, we're going to have 1/2 of the total quantity. It's going to equal to the total quantity at given time, e to the negative kt. And we're told that the half-life of this substance occurs in 20 years. So t is equal to the values of 20. And in this case, we're going to have to solve 1/2 a sub 0. It's equal to a sub 0 e to the negative k times the values of 20. Okay, so the first step is to technically divide by the values of a sub 0. Divide by a sub 0, and we're assuming that a sub 0 is not technically the quantity of 0, which in this case, we're obtaining that this is just 1/2. It's equal to e to the negative 20k. And then let me take the ln of both sides. And let me rewrite it as we're left with the ln of 1/2. This is equal to the ln of e to the negative 20k. And since technically ln and e's are inverse functions, these cancel. So we're simply left with the values of ln of 1/2 it's equal to negative 20k, and then we'll just divide by the values of negative 20. And let me rewrite it. In this case, well, the values of k is equal to the ln of 1/2 divided by negative 20. And let me evaluate this. Please punch it into your calculator. I'm getting that this is approximately 0.03 47. I'll round it to 4 decimal places. Okay, and what this allows us to do is technically obtain the mathematical model. In this case, the formula that's going to model this situation is just going to be A is equal to, we have a total of 3,000. Well, that's the amount. So it's going to be 3,000. And then it's going to have an E to the negative 0.03 47t. Actually, I'm missing the 7. 03 47t. And what we're going to do next is answer the question. Don't forget that this one happens to be an application. So all we're going to do is evaluate. They want how much quantity is left at 40 years and 50 years. So technically t is equal to the values of 40. We're going to have that a is equal to the values of 3,000, e to the negative 0.03 47 times the values of 40, and then also t at actually 50 years. And we're going to be evaluating the same formula. A is equal to 3,000 e to the negative 0.0347 and then 50. please punch them into the calculator. Let me evaluate them and tell you what I'm getting. For the first one, 748.7 and 529.2. So I'm just gonna round, since they want the nearest integer, 749 and approximately 529. Now remember that we have an application, so all of these will be expressed in some sort of a sentence. For the sentence, I already typed it up here, and the author's using units of bacteria. So for the first one, after 40 years, there's a total of 749 units and 529. So let me just put an arrow, since technically that is our final answer, but we're supposed to express the problem with complete sentences. That's actually it for problem 23.